talk about concept of how to convert the DFA to regular expression. To convert DFA to regular expression, we have to follow two steps. The first step is eliminate all steps except the Q naught and the final state. Generally, in DFA diagram, we have the start state and final states and intermediate states. So, how to eliminate all the intermediate states. Finally, we get the start state and the final state. So, we have to eliminate all state except Q naught and QF. Remove the final state. The second step is if Q naught is not equal to minus 2 means sometimes in diagram the minus and Q naught is same. Both are different. In that cases we get the diagram like this. R, S, U and T. R regular expression formula is R plus S into U star into T whole star into S into U star. And sometimes in the diagram the start state and final state is same. In that case we have to apply the third step if Q naught is equal to QF. Then if the start state is final state is equal, then we get the final solution, we get the circuit in this state. Yes, the desired regular expression is the sum of all derivations for each accepting state. Next one, we have to see the problem. Find the regular expression for the following finite automata using state elimination method. So all the above steps are using state elimination method. So to convert the DFA to regular expression, we are using the state elimination method. So it is diagram. In this diagram, we having three states Q0, Q1 and Q2. Q1 is a start state and Q3 is a final state. And we have the input simple 0 and 1. First, we have to eliminate the intermediate state Q2. So here we are taking four cases. Case 1, Q1, Q3. Case 3, Q3, Q1. Case 3, Q1, Q1. And case 4 is Q3, Q3. In case Q1, Q1, we are taking a part Q1 to Q2, Q2 to Q3. So R means here the subgroup of Q1, there is no subgroup in Q1, the value is 0. And Q means Q1 to Q1 state to Q2, the value is 0 in the diagram. And the subgroup of Q2 in diagram, the Q2 is not having the subgroup, so the value is 5. And P means Q2 to Q3, the value is 0. P value is 0. So we are substituting the R plus unit formula in this, and substituting values in this formula. R means 5 plus 0 into 5 star into 0. Then we get the value 0, 0. So from Q1 to Q3, we get the value 0, 0. Next, we are playing case 2. Case 2 means we are taking Q3 to Q1. For Q3 to Q1, we are taking intermediate Q2. For R means Q3 to Q3. The Q3 self-root is Q3 to Q1. There is no direct part from Q3 to Q1, so the value is 5. And Q means Q3 to Q2, the value is 1. And the S means the self-group of Q2, there is no self-group in Q2, the value is 5. And P means Q2 to Q1, the value is 1. Then we are substituting these values in the formula R equal to 5, Q equal to 1, S equal to 5, and P equal to 1. So we get the value 1. So for Q1 to Q3, for Q3 to Q1, the value is 1, 1. Then case 3. In case 3, we are considering another part that is Q1 to Q1. Next, for Q1 to Q1, we are taking intermediate state Q2. See R equal to 1 means there is self. And Q means Q1 to Q2, there is 0. And S means Q2 is self 5. And P equal to Q2 to Q1, there is no value for Q2 to Q1. There is a value for Q2 to Q1. The P value is 1. So after substituting these values in the formula, we get the value 1 plus 0, 1. Next, we are considering another part Q3 to Q3 by using intermediate state Q2. So R equal to 0 means there is no subgrouping or there is no direct path from Q3 to Q2, so the value is 0. And Q1 equal to 1 means for Q3 to Q1, in the diagram, the Q3 to Q1 is 1. And S equal to 5 means in Q2 there is no subgroup, the value is 5. And Q3 equal to P. P means Q2 to Q3. So Q2 to Q3, the value is 0. So after substituting all these values in formula, we get the value 0, 0 plus 1 into 5 whole star into 0, it is 0 plus 1, 0 whole star. Here general, the pi star means formula epsilon, by pi star equal to epsilon. So for Q3, the value we got is 0 plus 1, 0. By combining all these four states, we get Q1. We are applying all these four states, we get the R, S, T, and V. We have to substitute in the following diagram. We get this following regular expression. Next, we are taking another example, that is another problem, that is Q1 taking three states Q1, Q2, and Q3. For Q1, we are having the subgroup 0, and here also we having the two input symbols 0 and 1. Here also we are inventing the intermediate state Q2. We are including the state Q2, and here we have to observe that in first diagram we having only we are having for start state and final states are different, but in the second problem we having the start and final states are same. So the start state is Q1 and final state is also Q1. So we are inventing the state Q2. So for state Q1 to Q3, we are taking Q2 directly. So Q1 to Q2, Q2 to Q3. So R equal to 5, Q equal to 1, S equal to 1, P equal to 0. P means Q2 to Q3, S means Q2 self-proof, and Q equal to 1 means Q1 to Q2. In Q2 means there is no direct part from Q1 to Q3. So the R value is 5. So putting the formula, putting all these values in the formula. So R equal to 5, Q equal to 1, S equal to 1, and P equal to 0. So we get the solution 5 plus 1 into 1 star into 0 means 1 into 1 star 0. For Q1 to Q3, the value we got is 1 into 1 star into 0. And in second case, we are taking the state Q3 to Q1. For Q3 to Q1, we are taking the intermediate state Q2. So for Q3 to Q1, there is no direct path. So the value is 0 in the diagram, direct path from Q3 to Q1 is 0. So the R value is 0. S is the circle of Q2, that's equal to 1, and Q is nothing but a Q3 minus Q2. The Q equal to 1, and P means Q2 minus Q1. The value is 5 in the diagram. Since there is no value, so the value is 5. So we are separating R value, all these values in the formula. R equal to 0, Q equal to 1, S equal to 1 star, and pi equal to P means 5. So we get the formula is 0. So 5. And in case 3, we are taking the state Q1 to Q2, and we are taking the intermediate state Q2. So R equal to 0. R equal to 0 means there is no direct part from, we having direct part from Q1 to Q2. So the R value is 0. And Q equal to 1 means we are taking the Q1 to Q2. In the diagram, Q1 to Q2, the value is 1. And S equal to 1 means in Q2 there is no, there is having the subgroup. So the S is equal to 1. And Q2 to Q1 means the value, P value is 5. So after substituting value, we get the value is 0. After substituting the formula in the equation, we get the value 0. So 5 plus R into expression equal to R into expression. So the Q1 state value is 0. Last in case 4, we are taking the Q3 to Q2 and Q2 to Q3. So R equal to 5, Q equal to 1, S equal and P equal to 0. R means 5 plus 1 into 1 star into 0, that is equal to 1 into 1 star 0. So we get Q3 to Q3 first star to whole. So by combining all these first states, we get the value like this. Q1, Q3. So we have to eliminate the Q3 state also. For Q3, for eliminating Q3, we are taking the part Q1 to Q1. So Q3 is intermediate. So R equal to 0. For Q1 to Q1, we having the direct path. So we having R value 0. Q means Q1 to Q3. Q1 to Q3, we having the value Q equal to 1 star 0, and S equal S means Q3 is self, that is 1 into 1 star 0, and P equal to 0. P means there is P means there is no intermediate state, so the P value is 0. And here R plus Q into S star into P. Therefore, R means 0, Q means 1 into 1 star into 0, and S means 1 into 1 star into 0, and P equal to whole star into 0. So after substituting, we get the regular expression like this. So to convert the regular expression from DFA to To convert DFA to regular expressions, we have to follow this first step. The first step is we have to eliminate all the start state and intermediate to final states. If the Q naught is not equal to QF, then we get the regular expression R plus S into U star into T whole star S into U star. If Q naught equal to QF means we get the only single state and the state is having the for loop. The desired regular expression is the sum of all derived for each accepting state. So once again, I am repeating the problem. Find the regular expression for the following DFA using state elimination method. Here we are taking the DFA diagram. We have to convert the DFA diagram into regular expression. So here I am eliminating. We are having start state Q1 and final state Q2. At the end, we have then only final and start state have to remain. The remaining states are eliminated. So here the intermediate states are Q2 must be eliminated. So for that purpose, we are taking the three cases. One is Q1, Q3, start state and final state. We are taking the combination Q1, Q3, Q3, Q1, 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 Q3, Q3. Like that, we are taking the combinations. For case Q1 to Q3, we are taking intermediate state Q2. Here in the diagram, we having there is no self-loop direct path from Q1 to Q3. So R value is 0. So next one for Q means the formula is Q1 to Q2 value is 0. Q2 means there is self-loop for Q2. There is no self-loop in Q2. So the value S value is 5. And P means Q2 minus Q3. The P value is 0. So you have to substitute formula in the equation R plus Q into S star into P. So with this pi star equal epsilon, so we get the value 0, 0. Q3 to Q2 minus Q1. So R equal to Q3 minus Q1. Q3 means minus Q1 means here there is no direct path from Q3 to Q1. So the value is 0. Q equal to Q3 minus Q2. Q equal to 1. S equal to Q2. Q2 equal to 5. P equal to Q2 minus Q2. The P equal to 1. So R plus Q into S star into P. So pi plus 1 into 4 star equal to 1. That is equal to 1, 1. So Q1 to Q3 the value is Q3 to Q1 the value is 1, 1. Then next we have to consider another part Q1 to Q1. For Q1 to 1, we have taken the intermediate state Q2. So R equal to 1, Q equal to 0, S equal to 5, P equal to 1. So 1 plus 0 into 5 whole star into 1 that is equal to 1 plus 0, 1. For Q1 to Q1 the value is 1 plus 0, 1. Consider that we are considering another part that is Q3 to Q3. For Q3 to Q3, where I am taking the intermediate state Q2. So R equal to 0 means there is no direct path from Q2 to Q3 in the diagram. So we have a direct path from Q2 to Q3. The value is 0. So R equal to 0. Q equal to 1 means Q3 to Q1 in diagram. The Q3 to Q1 the value is 1. And in diagram, the Q2 does not have its self-loop, so the value is 5. And Q2 to Q3, the P value is 0. So we are substituting all these values in the formula. We get the solution is 0 plus 1, 0. So by combining all these formula, all these steps, we get all these 4 steps. We get Q1 to we remain only Q1 state and Q3 state. So R means 1 plus 0, 1, S means 0, 0, U means 0 plus 1, 0, and T means 1, 1. So we get R, S, T, and U values. So you have to substitute in the formula. The regular expression R plus S into U star into T into whole star into S into U star. So R means 1 plus 0, 1 plus 0, 0 into 0 plus 1, 0 into whole star into 1, 1 whole star. 0, 0 into 0 plus 1, 0 whole star. Like that, we have to convert the DFA into regular expression. So if there is having more than 2 intermediate states, then we can have to follow these steps only. Sometimes if having one start state and final, but we having 2 to 3 intermediate states, then only we have to follow these steps. So the first step we have to identify in this formula is we have to find the start state and the final state. So we have to eliminate all the intermediate states except the start state and the final state. And second case is if the Q naught state, the start state and final state is not equal, then we get two states in the final solution. One is start state and then one is final state. And we have to use it and have use it R, S, U, and T. So we have to apply the equation formula R plus U R plus S into U star into T into whole star into S into U star. If Q not equal to final state means if there is sometimes in the diagram, in the DFA diagram, we have star state and final state is same. In that cases, we are taking Q not equal to QF. So the desired equilibrium expression is a union of all derived for each accepting state. Thank you, one and all.